All right, here we go. The first time I recorded this, the audio didn't export with the video, so we are going to try this again. Today, we will be looking at bone formation, growth, and remodeling. Specifically bone formation today. Later this week, we will go through the second half of these slides and discuss the bone cells and how the bone forms into its functional units. So for today, we are going to be looking at bone formation. As an embryo, you have no bones. Instead, the skeleton is made up of hyaline cartilage, and as we grow, this hyaline cartilage is going to be replaced by bone. As a young child, this hyaline cartilage starts to get replaced, and it remains in a few isolated areas. Those areas include the bridge of the nose, the costal cartilage around the ribs, which is this bit here that connects the ribs to the sternum, and then the articular cartilage, which we can see here at the ends of these joints of the long bone. So ossification is the process of becoming bone. The root, oh no, I broke it, not really. The root os means bone. Os, ify, means to become, and ation is the process. So ossification is the process of becoming bone. I'm going to delete all of that there, I guess. And the definition of this is just bone formation. There are two types: endochondral ossification. Endo meaning within, chondra meaning cartilage. So endochondral ossification starts with cartilage, and this is when the bones develop using hyaline cartilage as a template or a model. Then we have, the process of turning these models into hard bone. Then we have intramembranous ossification. Intra means inside, and intramembranous ossification is the process of turning a membrane into a bone. So there are a few different types of bone cells. Osteoblasts are the cells that form bone. They deposit bone matrix and eventually become osteocytes, which are the mature bone cells. So here is the process of endochondral ossification. We have a cartilage template here that looks vaguely bone-shaped. This is the first thing that will develop in the developing embryo. Then we have what's called a primary ossification center develop. This primary ossification center is the first place where that bone growth is going to appear, and it's going to be right here in the middle of the diaphysis. And then, right there in the middle of the diaphysis, we're also going to have the periosteum begin to develop. Peri means around, so the periosteum wraps around the bone, and so you can see it here on the edges of the bone, but this is actually going to go all the way around because it is the covering that goes around the bone. It wraps it like pigs in a blanket. It is not going to just be on the edge that we're looking at right here. They just had to cut it away so we could look at what's happening in the middle there. So after the primary ossification center develops, we're going to have the infiltration of blood vessels into this area and also into these secondary ossification centers here. So these secondary ossification centers are the second places where the bone growth is going to develop. And it's going to happen in both of the epiphyses at the same time. While the epiphyses are starting to ossify or become bone in the middle, we're going to see an expansion of the primary ossification center as well. Then this primary ossification center is going to basically go through the entire bone. It's going to hollow out this medullary cavity in the middle, and we're going to see expansion of the epiphyseal ossification at the secondary ossification centers as well, until eventually we have a whole bone. And in this case, we're going to have compact bone around the outside here, and we're going to have a little layer of compact bone around here, and then we'll have our spongy bone there at the epiphyses with our medullary cavity that's hollowed out right here. And what we're going to be left with is some articular cartilage, articular cartilage there at the ends. And then we're going to be left with this line right here. And this line is going to be called the epiphyseal plate. And this is where we're going to have bone growth continue to occur throughout childhood. And it's going to allow the bone to grow in this direction, which is lengthwise. So we call that longitudinally. And that is the process of endochondral ossification. Endo, because it starts within, on the inside of cartilage, and eventually we will have a whole bone through that process. Here is the step-by-step description of endochondral ossification. In terms of what you need to write down, basically everything on this page. You will have the opportunity later to add information about the types of bone cells. So I'm not worried about that for today. For today, what we need to know is this 6-step process. I am going to go to the next slide here in a minute. And by a minute, I mean like 10 seconds. So go ahead and pause this right now so you can stay on this slide. All right, so endochondral ossification. At birth or shortly thereafter, most hyaline cartilage has been removed or been converted to bone. So at birth, we would be looking at something between here, depending on individual development and the time when the baby is born, gestationally speaking, etc. Growth is going to continue at the epiphyseal plates, which are right here. So the epiphyseal plates are going to allow for the bones to continue to grow. Okay, so here are our epiphyseal plates. They provide for longitudinal growth of long bones throughout childhood. So here is where we're going to see the bones continue to add length to that bone. This is going to end around age 18. Really, it could be anywhere between like 16 and 24, depending on the sex of the person, hormones, etc. So the bone growth is controlled by hormones. One of the major ones is the growth hormone, but it's also controlled by sex hormones, and now I can't go back, sorry. So that would be why males tend to be taller than females when controlling for genetics. Here's another picture of an epiphyseal plate. So we've got a sketch over here, and then we have a radiograph over here, and we can see what that looks like on an x-ray. So we've got two epiphyseal plates here. This one is on the femur bone. Yeah, I think that is the femur. And this one is going to be on the tibia, and we'll see growth at both of those locations. Intramembranous ossification is the other type of ossification. You are going to want to write this down as well in your notes. So intramembranous ossification, intra means inside, membranous refers to a membrane. So this is going to be bone growth that occurs within a membrane. This is the type of ossification that is going to create the flat bones like the skull. So what's going to happen is mesenchyme cells are going to form a membrane, and instead of creating cartilage to form that template into the bone, the membrane is going to be the template that becomes the bone. So osteoblasts will secrete the extracellular matrix and deposit calcium, and that membrane will ossify or become bone, and that's how you get flat bones like the skull. This is slide 11 of the slides. If you need to pause right here, now would be an excellent time to do that, because I'm going to the next slide in 3, 2, 1. So we are going to start on slide number 12 when we return to these slides later this week.